This is problem 9 of the exam review, and for problem 9 it says for 5 states A, B, C, D, and E, give state assignments using a minimum number of flip-flops, and B, one hot encoding. So first let's talk about minimum number of flip-flops. So if you have the number of states, the number of states and has to be less than or equal to 2 to the n, where n equals number of flip-flops. So let's see what I mean by that. So if I have one flip-flop, so number of flip-flops. If I have one flip-flop, then I can have less than or equal to 2 to the 1 equals 2 states. If I have two flip-flops, then I can have less than or equal to 2 to the 2 equals 4 states. If I have 3 flip-flops, then I can have less than or equal to 2 to the 3 or 8 states. And if I have 4 flip-flops, I can have less than or equal to 2 to the 4, which are 16 states. So if, for instance, I want to have a machine that has 6 states, then I need to have 3 flip-flops, because at least 3, I could have more than that, but at least 3, because if I had 2, the maximum number of states I could have is 4. But I have 6 states, and so I need to have 3 flip-flops. If I had 10 states, then I would need to have 4 flip-flops, because one less than that, 3 flip-flops, I would only be able to have 8 states. So that's how you configure the minimum number of flip-flops. So for part A here, where it says minimum number of flip-flops, we have 1, 2, 3, 4, 5 states. So 5 states means we need to have 3 flip-flops. And there is not a unique way to do this. You can do it in all kinds of different ways. It just needs to be that each state has a different assignment, A, B, C, D, E, and the only thing is I'm going to have a 3-digit number, and each of these needs to be different. I'm kind of boring, so I'll just do them in order. So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, and 1, 0, 0. So that's the answer to part A. That is one answer to part A. There are lots of answers to part A. You could scramble these around. You could use some of the ones that I didn't use. It's up to you. Now, one hot encoding, what that means is for each state, one and only one bit is 1. The others are all 0. So for one hot encoding, you need to have the number of flip-flops as the number of states. So for one hot, number of flip-flops equals number of states. So we have 5 states, so we need 5 flip-flops. And again, it's not unique how you do it, but it is important that only one and only one state is 1. So for A, I'll have 0, 0, 0, one and only one digit is 1. 0, 1. B 0, 0, 0, 1, 0, C 0, 0, 1, 0, 0, D 0, 1, 0, 0, 0, and E 1, 0, 0, 0, 0. So that would be one hot encoding. Now notice we didn't break the rule that we had over here. I used 5 flip-flops, and so 5 would mean I could have less than or equal to 2 to the 5th equals 32 states. But that's less than or equal to. I can have any number of states less than or equal to 32. So I use 5 flip-flops, and I have 5 states. And that's how you do one hot encoding.